you have your name turned off, your last name turned off
Let me do that.
or deleted? You know how to do that?
Yes.
Again, just to try to keep more anonymity in case we become famous. All right, so we are talking to Dylan about pre-calculus. We're talking about inverse functions and graphing, etc. So this says graph both the function and its inverse on the same plane, then find the equation of the inverse of the function, and then state the domain and the range. So this function, I'll graph this with red. I think we'll be able to see okay. So f of x is going to be in red, and you'll see that it's the cubic function, right, which looks like this. Right, but then it shifted where? Where does this -2 shift it?
Across the y-axis.
So how much does it shift?
To the right 2.
2, yep, right 2. And what does the +1 do?
Up 1.
Good. So instead of starting at 0, 0, 0, 0, it starts at 2, 1, and then it goes up 1 to the right and over 1, and it goes down 1 and over 1, and then it goes over 2 and up 8, so it'd be up here somewhere, and it goes left 2 and down 8, so it'd be down here somewhere. You understand how I came up with that?
Yes.
So there's your function. In fact, we can even kind of put those values in if we want, and that will help us to graph the inverse. So this point right here is 2, 1, kind of hard to see. 2, 1, so let me just write those points over here. We have 2, 1, and then I went right 1, so that's 3, and up 1, so that's 2. You understand how I'm coming up with that?
Yes.
Write that below. 3, 2, and then I went right 2 from there, so that's going to be 4, and then I'd have to go up 2 cubed from there. So if I go up 2 cubed, which is 8 from here, I'm up to 9 now. Right, so 4, 9 is my point. You understand how I came up with that?
Yeah.
Okay, and then if I go left 1, this point, I go down 1, so that point is 1, 0. And if I go left 2, I would be at 0. I would go down 8 from 1, and down 8 from 1 is at -7. Okay. So those are my points. And the reason that I would want to write that is because then if I want to find the points of the inverse, one of the ways of finding an inverse, which I'll do in yellow, is you just flip the coordinates. So for f inverse of x, your point would be -7, 0. I'm flipping the x's and the y. 0, 1, 1, 2, 2, 3, 9, 4. Understand how I came up with that? So -7, 0 is right here. 0, 1, 0, 1 is up there. 1, 2, 1, 2 is right there. 2, 3, 2, 3 is up here. And 9, 4 is over here somewhere off to the right. So your graph looks like, oh, and by the way, let me also draw in my line y equals x, because this is really nice to have. Here's the line y equals x, goes perfectly through on a diagonal. So this point is going to be intersecting wherever one of them intersects the xy, the line y equals x, the other one's going to also intersect there. I don't have to actually find the point, but I know it's going to cross there. You understand what I'm saying?
Yes.
So there's my graph. Something like that. And that blue line is the line y equals x. So you can see that the line y equals x, the functions, the red function, which is f of x, and the yellow function, which is the inverse, are a reflection over that line. Make sense?
Yes.
Okay, now how do we find the inverse? Well, to find the inverse, we switch x and y in your original equation. See how I switched x and y? And now I solve for the new y. So I add 1 to both sides. So x plus 1, x minus 1 equals y minus 2 cubed. Let me know if you're confused. Now I take the cube root of both sides. So the cube root of x minus 1 equals y minus 2. And now I add 2 to both sides. So I'll just write that down here because here's the inverse. F inverse equals the cube root of x minus 1 plus 2. See how I did that?
Yes.
Now the domain and range for this one actually happened to be pretty easy because there's no restriction on either. There's no restriction on the domain and range of either one of these. So the domain and range for both of these are infinity to negative infinity to positive infinity. Because there's no asymptotes or anything like that we have going on. You can plug in anything you want and you're always going to get any of the y values as well for it. That makes sense? Any questions about how I did that? I know I did that kind of fast, but I showed you all the different ways to kind of think about inverses. So again, to review 3 main ways to think about inverses. You flip the x and the y to get so you can like get points, you can get a set of points and then just interchange the x and the y and that's your inverse. You can draw the graph of 1 and then reflect it over the line y equals x. That's one way. Or you can take your equation and you can interchange the x and the y and then solve for your new y, and that gives you your function, your inverse function. So those are the 3 main ways to do it as concisely as possible. And the domain of f of x is going to be the same as the range of f inverse of x. And the range of f of x is going to be the same as the domain of f inverse. Why? Because you're switching the x and the y. Right? Everything that inverse has to do with is the fact that the x's and the y's kind of get interchanged or flipped. And that's also why your equation y equals x is the line of symmetry, or the axis of symmetry. You want to put another one up there for us?
I think there should be one on 6.
Oh, nice. All right. So now this is a piecewise function. So this is slightly different. With piecewise functions, let me make this a little bit bigger so we can see it better. See if that'll work. Hold on, it's not showing up big like I was hoping it would. Sometimes I have to close it down and open it back up for the changes to take place. There we go. So piecewise function. So what we're going to do with the piecewise function is we're going to look at, I'm going to show you, since we have this nice iPad that I can work with, I'm going to color code everything. So first of all, when x is less than -1, so everything to the left of here, it's going to be this graph, which is a parabola, right?
Yeah.
It's a parabola that shifted left 2, down 1, and then it's stretched by a factor of 2.
Okay.
So I'm going to erase that line. I'm just going to draw the entire graph in. So it's shifted left 2 and down 1. So there's your new vertex. Left 2 and down 1. And instead of going over 1 up 1, because of this number 2 in front, it's going over 1 up 2. So I'm actually creating it without making a table of values, by just understanding what this is doing. And same with going to the left. Instead of going to the left and up 1, which it normally does, because remember, -1 squared is 1, right?
Yeah.
But now we're multiplying that by 2, so it's actually up here.
Yeah.
And then instead of going over 2 up 4, which you normally would do, it's over 2 up 8. So I'm going 4 more. 1, 2, 3, 4. So up there. And same with on the left side. Up here, it's symmetric, right? So there's my graph. But remember, this is only defined where x is less than and not equal to -1. So I'm going to go back and I'm going to take this point. I'm going to erase that point up there, 0, 8. That was not necessary. And this point, -1, 1, I'm going to make it an open circle. You understand why?
Yeah, because it's not equal to.
Perfect. And then I'm going to draw in my parabola, but I'm stopping it at that circle, at that open circle, because that's where it stops.
Mm-hmm.
Okay. Now let's do this one in blue. What's the equation for? What's the equation y equals 4? What does that look like?
Just a straight line.
Okay, all lines are straight. Do you mean vertical or horizontal line?
Y equals 4, it'd be vertical. No?
Nope. Think about what does for this point, does y equal 4? For this point, does y equal 4? For this point, does y equal 4?
No, sorry, horizontal.
No. So it'd be horizontal, right? So if y equals 4, that means that all of the y coordinates are 4. It doesn't matter what the x coordinates are. All the y coordinates are 4. So it's this line. But what kind of circle am I going to put at -1, 4? Am I going to put it open or close?
Closed.
Good. And how about at 2, 4?
Open.
Good. And then it's just a horizontal line between them. Got it?
Mm-hmm.
And then the last one in yellow is a square root function, but it's shifted right 2 and up 3. And it's also what? Flipped over.
The x-axis.
Yeah, when you put it on the outside, it flips over the x-axis. Good. So it's shifted. So it's this. It's right 2, up 3, 1, 2, 3, but it's shifted. Instead of going up like this, it goes down like this. So remember, it's going to go down 2 over 4. 1, 2, 3, 4. So right there. And it's always good just to put some points in to make sure you're doing it right.
Mm-hmm.
It's going to be a half parabola like that, which that's not a very good looking one. Let me try to undo that, make it a little prettier. Still not that good looking, but. And to just check a couple of points, plug in 3. And if you plug in 3, 3 minus 2 is 1, square root of 1 is 1, -1 plus 3 is 2. So 3, 2, yeah, that checks out. Plug in, what point is that? 5, 6. Plug in 6. 6 minus 2 is 4. Square root of 4 is 2. -2 plus 3 is 1. See how that works?
Yeah.
Now, should that be an open circle or a closed circle?
Open.
Good. That should be an open circle. So they're probably going to ask a question like this. What's the domain of that function? Can you tell what the domain of that function is? Of that entire function?
The domain is -1 to infinity.
Nope. Remember a horizontal or a vertical line scan. Will this line touch the graph eventually? Over here?
No.
Are you sure?
Yeah.
It will eventually, because this one, the parabola, that red parabola, does it ever stop moving to the left?
No.
No, it never stops. So is this line eventually going to be touched?
Yeah.
Now, how about this one? How about this one? How about this one? And this one, and this one, and this one, and this one? Is there any line you can draw that's not going to touch this graph?
No.
Careful. There is one line you can draw that won't touch the graph. Can you see what that is? How about this one right here?
No, because they're both open circles.
They're both open circles. So this was kind of a little bit of a tricky one because usually they have one open and one closed. So the domain of this, I'm just going to write it so you know, is from -infinity to 2 union from 2 to infinity. In other words, it's everything but 2.
Okay.
Make sense?
Yes.
Do you need help with number 8 on this page too, or no?
Yeah.
Okay, so function composition, they want us to plug basically what we're doing. I'll color code this again. We're gonna make g of x yellow, and we're gonna make f of x red.
Okay.
Okay, so f of g of x, color coding just makes it look a little bit better.
Mhm.
Means I'm literally plugging in every time I start writing out f of x, instead of writing the x, I'm gonna write the g of x inside there instead of x, because that's what it's telling me to do. And g of x is x plus 3. So everywhere I just write x plus 3. And now when I do this, when I do the math here, this is going to equal x squared plus 6x plus 9 minus 2x minus 6 minus 1. You see how I did all that?
Yes.
Okay, so check, make sure you know that you're not just distributing this 2 in. You have to multiply x plus 3 times x plus 3. So you FOIL it out. If you don't know that, do it and you'll see. And this -2, I distribute the negative with it. Don't forget to do that. So these both become negative. So now that simplifies into x squared plus 4x, 9 minus 7 is 2 plus 2. X squared plus 4x plus 2. So that is f of g of x. Now let's do the other one, because they're not going to be the same,
Yeah.
at least not necessarily. So g of f of x, so I'm now plugging in the red f of x into g of x. So I will write out my f of x. So f of x is x plus 3. So it'll actually be easier. So I plug in x squared plus, minus 2x minus 1. I plug that in for the x, all the x's, which there only happens to be 1. So this was easier, right?
Yeah.
And then I just simplify that. So this equals x squared minus 2x plus 2.
Okay.
Okay.
Yeah.
All right, more questions. Put a couple more on there. This is good. We're cruising through. Again, I suggest, I know it's hard when we only have a half an hour together, you want to just get all your questions answered, but I would suggest you go back, you even rewatch these videos and you pause it and try it on your own, like on a separate piece of paper, to see if you can do it, and then watch the video again and see if you did it right.
Okay.
All right, this question says, find the domain of the following functions in interval notation. All right, we don't actually need it that big right here, because I'm going to want to just use the white screen. Okay, so instead, let's make that smaller again, and I'm going to add a white screen. You can, I'll teach you how to do this too, so you can do it if you ever need to. If you're on a PC, over on the left, this won't work on a iPad or on a phone, but if you click on the shape, you can just insert a shape and then make the border color white, and then it'll just crop it for you, because they don't have a crop functionality in this. All right, so it says find the domain of the following in interval notation. So the domain of this thing right here, of this square root, remember when you have the square root of something, what are you not allowed to take the square root of?
0.
You can take the square root of 0.
X.
You can take the square root of x, as long as x is not what kind of number?
Oh, a negative.
Right. So this whole thing right here, try to follow my logic. This whole thing here can't be negative.
Yeah.
So there's a couple ways you can think of this problem. There's a couple ways that I've seen it taught. I prefer to do it in 2 dimensions, but you can also do it in 1 dimension. What you can do is you can just write out the equation. X squared minus 2x minus 15 has to be greater than or equal to 0. Because this whole thing, this the number underneath the radical, I think that's called a radicand, has to be positive. So how can I know that this is positive? Well, what you need to do is you need to find out what this graph looks like. That's why I like to do it in 2 dimensions. So let me just jump over real quick to a graphing calculator. And let's take a look at what it looks like. I'm using Desmos right now. So if I plug in y equals, I'm plugging in this formula, x squared minus 2x minus 15. And tell me what you notice about this graph. Where is that graph greater than or equal to 0? Can you see where?
Yeah.
All right, I'm gonna copy this. Can you see that it's greater than or equal to 0
Yeah.
for all of these points here and for all of these points here? In other words, it's greater than or equal to 0 from here over and from here over.
Mm-hmm.
Do you understand that?
Yeah.
So that's what we want. We want to find out what this point is right here. And in Desmos, I can just tap on it and it'll tell me that point is 5, 0. And what this point is right here, that's -3, 0.
Okay.
Okay, does that make sense how I
Yeah.
did that? So
Yeah.
now I'm going to show you the way to do that without Desmos or a graphing calculator. I mean, you can use a graphing calculator, but we're doing, this is what I'm saying is a 2-dimensional look at it. To graph this, you're going to factor it. So it's x minus 5 and x plus 3. That's the answer, or that's the x minus 5 and x plus 3. Okay, which
Yeah.
means if I'm trying to graph this equation, what I would do is I would set each one of these equal to 0. Remember doing this?
Yes.
And that's going to give me my zeros. So x equals 5 and x equals -3. Those are my zeros. So my 2-dimensional graph, I know my 2-dimensional graph, I know there's going to be a 0 at 5. And I know there's going to be a 0 at -3. And I know this graph is opening which way, up or down?
Up.
Yep, it's opening up because it's positive. So I actually can just do this. It doesn't matter where the vertex is. None of that matters.
Okay.
All I want to know is where is that graph positive and where is it not positive? Because these numbers here, you can't plug these numbers in for x because you would get a negative number out if you did.
Mm-hmm.
Test and you'll see, plug in 0. If you plug in 0 for x, you're going to get -15. You can't take the square root of -15. So that's not part of the domain.
Mm-hmm.
If you plug in 5 for x, you're going to get 0. And you can take the square root of 0.
Yeah.
If you plug in 6 for x, you're going to get a number bigger than 0. And you can take the square root, etc., etc. You understand?
Yes.
So that's the 2-dimensional version of it. Now, what teachers will show you is they'll just show you, hey, just do this. They'll do this thing right here. And then they'll say, hey, now make a chart. They'll say, make a real number line and put -3 here and put 5 here, and then do a sign analysis. Find a number over here that's somewhere in here. Pick any number, like -4, pick any number in here, like 0, and pick any number over here, like 6, and do an analysis and see if those signs are positive or negative.
Yeah.
And you'll find that this is positive over here, this is negative in here, and this is positive in here after you plug in these values into the function. But in my opinion, that takes a lot more effort, especially now that you guys have graphing calculators, than just plugging this in a graphing calculator or factoring it by hand and figuring out using your end behavior, knowing that it opens up to figure out, oh, this goes up to the left and it goes up to the right.
Yeah.
Hopefully that made sense. Okay, for number 2, do this real quick here. For number 2, the way you do this problem, you have the square root of x over, what does it say, x minus 7?
Yes.
Okay, so there's 2 problems that you have with this function. There's 2 problems. One is having a square root, and what did we just talk about? What can you not take the square root of?
A negative.
Good, so you know that x has to be greater than or equal to 0,
Mm-hmm.
right?
Yes.
And then for this one, what's the taboo for a denominator? What can you not divide by? What's the only number you can't divide by? What's the only number that doesn't go into other numbers?
0.
0. So you set the denominator equal to 0, or not equal to 0, I should say, and then you solve it. X cannot equal what? What can X not equal?
0. Oh.
No, X minus 7 can equal 0. What can X not equal?
7.
Because if X equals 7, you would have 0 in the denominator.
Mm-hmm.
So we have two restrictions on our domain. X has to be greater than or equal to 0, but it can't equal 7. So how do I write that in interval notation? I write 0 to 7 union 7 to infinity.
Mm-hmm.
That make sense?
Yes.
You know, this first one, we didn't actually write it out. How do I write this first one in interval notation? How do I write this? I say, I'll just do it. Negative infinity to what?
Which one?
The number 1 from this last page.
Negative infinity to -3.
Mm-hmm.
And then
Including it or not including it?
Including it.
Good. So I put a bracket like that. Union, then what?
And then 5, including it. And then 2, infinity.
Perfect. You got it. All right. Sound good? Feel good about that?
Yeah.
All right. Well, good luck with it. You can watch that again.